Hello again. I'd like to show you in this video how to find the equation of an exponential growth or decay type situation given 2 points that exist on that exponential curve. In this case, we have a scientist studying the evaporation of a chemical solution. After 4 minutes, the solution covers a surface area of 175.67 centimeters. At 9 minutes, the surface area goes down to 128.92 centimeters square. From these two data points, construct the mathematical model that models the evaporation of this certain chemical solution. So first off, we should identify that from 4 minutes to 9 minutes, it's going down from 175.67 to 128.92 centimeters. Therefore, it should model an exponential decay problem. And one of the first things you should want to do is to label your points. So we know we have 4, and let's see, get this 175 0.67 centimeters. And also we have 9 and 128.92. Let's see, this isn't working. Let's try the mouse. 92. So given those 2 points, we're able to get an idea what this would look like. So the first thing we want to do is probably graph this information. So what I do first is I take the first point and call this 4, and this would be our point here. So that would be at 175.67, and at 9 it will be down to 128.92. And we could put that point right there. Let's see, right there. And so the curve, just to kind of get an idea, would look something like this. It's decaying exponentially. So we have a nice curve there. And so given 2 points on this, and knowing after a total of, or a difference of 5 minutes, it will decay from 175.67 to 128.92. And from that, those 2 points, we should be able to derive what the rate of change is. So writing the equation, if we start at initially 175.67 times B, our rate, after 5 minutes, the difference between 4 and 9, it will go down to 128.92. Now from there, it's just a matter of solving for B, so we divide both sides by 175.67, 175.67. This cancels out. Now, to get B by itself, you want to raise the power to its reciprocals, and the reciprocal of this would be, let's use a different color here, so we raise it to 1 over 5, the reciprocal, because the power on power rule would be 1/5 times 5 would be 1, power 1 for b would just be b, but we have to do the same thing to this side as well. So we raise this to the 1/5 power, and once you do your calculations, we can determine, and with a little rounding, it's about 0.94 equals b. So we can write our equation now in this form. Let's use blue. We can say that y equals our initial starting point, and remember that's just kind of a pretend starting point, 175.67 times 0.94 to the power of x. So that goes with this equation here. But we know that it's at 4 minutes, it goes to 175.67. We want to know when is it at 0 minutes. So we want to change that 4 to 0, and what we want to do is move this function over 4 units to the right. So we want to move this over 4 units, so 4 would be about here someplace. So that would be our new scale, and so we want to move this over 4 units. We want to move this also over 4 units, estimating 4 units. And so we would get a different graph. Let's use this. So the graph would look something like this. And go in this direction. So that would be the true graph that we want. And to do that on here, we would just, in our function, as in any function, quadratic, square root, absolute value, trig functions, if we subtract 4 from x, that creates this new curve here, or just a shift over 4 units. So this is our true curve, but we don't have the true initial starting value. So to get that, we want to know what is our y-intercept, our initial starting value, when it's 0. So when x is 0, we should be able to find our true y-intercept, or our initial starting value. So we just take this x here, and let's see, take this x, and let's make this 0. So now our new equation is going to be, or to find out what the y is when x is 0, we get let's see, y equals 175.67.94 to the -4 power. That tells us when x is 0, what is y. And when you calculate all this out, it will approximately be 225. So now we have our initial starting value, we have our rate, and so our answer to our equation is going to be y equals 225 times the rate of 0.94 to the power of x. And that gives us our modeled equation given those 2 points. This equation will decrease by 6% every time for every minute. The surface area will decrease. And we have our initial starting point at 225. And you're able to answer a lot of different questions like what is the surface area after 20 minutes? Or you can also say when it is 100 square centimeters, how long does it take to get there? And questions like that. Hopefully this was helpful. Thank you very much.